Okay, just a minute. Conditions of equilibrium is that net force should be zero or resultant force should be zero and net torque is zero or resultant torque is zero. This is simple. Okay. Sum of the forces acting on the object must be zero. And number two, the sum of the torques acting on the body should be zero. And the object will be in. Okay. Now go to the next topic. Yesterday I started this couple. So you can see here the couple, the
Yes, sir.
bar, and the two forces are acting. They must be in opposite direction and they must be equal and they should not act on the same line. So examples of couples, just opening of a tap. We use two fingers. Suppose we are using two fingers to open the tap. The force applied by the one finger is upward, and the force applied by the second finger will be downward. They must be equal so that the object will rotate. Next, steering wheel is the another example. Steering wheel, while turning the vehicle, you know that if we are holding the steering with both the hands, so we'll apply the force. Suppose right hand we are turning left side. So right hand will apply the force in upward direction, and left hand will apply the force in downward direction. Right? It's a right hand. Suppose you want to turn right side. Okay, right side. So your right hand, you'll pull your right hand towards you, and the left hand, the force applied in opposite direction. So this is a right example. So let us see the few important points about couple. Number one, you can see on the screen. Forces must. Sorry. Excuse me, sir. Sir, can you show the previous slide for 1 second? Yes, sir. Done. Now let us see the important points about couple. Already I have discussed these things. Number first point, you can say that the forces must be equal. The two forces, okay, must be equal. Second point, you can see forces must act in opposite direction. This is also you have seen in diagram. The two forces must act in opposite direction. Third point, forces must act at a different line of action. They should not act at the same line or same point. Okay? So third point is very important
Yes, sir.
Here you have few examples of a couple. Turning of water tap, opening or tightening the cap of a bottle, turning of the steering wheel, turning the handle of a bicycle. All are the example of couple. And now everybody till now couple. An example about couple.
Example, sir, in the example of turning a water tap, how are the forces in the upward and downward directions and not in side direction?
Okay, okay, okay. You draw a rough diagram of water tap. Okay, very difficult for me to draw the water tap. Suppose this is the water tap. You see the rectangular bar. Okay, to open the tap or to close the tap with the two fingers, one force act in this direction by one finger, and another force will act on the other hand in outward direction. Okay, so this top portion is the example of couple. Okay, with a single finger, you cannot open or close the tap. You must apply at least two fingers. Okay, just try to understand. Suppose you are using the thumb and the forefinger, and to open or close, if you rotate the tap, okay, the two fingers will move in opposite direction. So force applied on the tap must be in opposite direction. Understood? And upward and downward. Because when we say no upward and downward means sideways, sideways.
Okay, sir.
In the diagram it looks upward.
just so that the in small amount of force applied, the it may show larger movement.
Okay, okay. Both of you are correct. Okay. So let us see all of you listen here. To open the door or to close the door, torque is required. Torque is required. And suppose that value of torque, suppose 100. I'm writing torque into 100 Newton meter. To open the door or to close the door, 100 Newton meter torque is required. Suppose. Okay. Now, you know the perpendicular distance is measured from where the object is pivoted or the line of rotation or axis of rotation. So in this case, the perpendicular distance is this. The red line I have drawn, that is the perpendicular distance. So if the handle is more towards right side, then this perpendicular distance will be more. Right? Now, so give me the value of this perpendicular distance. Suppose 1 meter. At present, the perpendicular distance is equal to 1 meter. Now, how much force is required to open the door? You know, torque equal to force into perpendicular distance. So force equal to torque by distance. Torque is 100. 100 by perpendicular distance is 1. Answer is 100 Newton. Clear? Force required is 100 Newton. Now, if I shift the handle to the middle of the door, you see the diagram, I'm shifting it. Now, in this case, what will be the perpendicular distance? More or less than 1 meter.
So let
Suppose 40 centimeter or 50 centimeter or 60 centimeter, whatever it is. Okay, so I'm writing 0.5 meter. 50 centimeter. So if the handle is fixed on the middle, how much force is required to open the door? Let us find. F equal to torque by distance. Torque equal 100 by distance. This time 0.5, 0.5. So your answer will be 200. It means that if the handle is fixed not far away from the axis of rotation, then more force is required. You see, in the second case, force required 200 Newton. Okay, that's why to reduce the force, I think you practice it in your home. Like you try to open the door by applying force at the middle of the door. You'll see more force is required to open the door or to close the door. Right? So more is the perpendicular distance. It means when the handle is far away, perpendicular distance is more. So less force is required to open or close the door. ठीक है, हैंडल जितना दूर होगा, perpendicular distance उतना ही ज्यादा होगा, और force required to open the door or to close the door will be less. ठीक है? I hope you understand.
yes, sir.
So this is the answer. You can see answer. To open anything, we have to apply some torque of magnitude equal to F into D. F into D. F is the force and D is the perpendicular distance. If the handles are fixed far away from the hinges, we increase the distance, and so to open the door. So it will be easy to open or close the door. Okay? So I hope all of you understand this. Next question, all of you see the question. Heavy vehicles, देखा होगा कि heavy vehicles, suppose a bus or a truck, big truck, okay, bigger steering than that of a smaller vehicle. तुम्हारे घर में जो कार है, you see the size of the steering will be smaller than that of the steering of bus or a truck. So heavy vehicles have bigger steering than that of the smaller vehicle. But same reason, if steering will be bigger, the couple arm will be bigger, so less force is required to rotate the wheel. You see the answer? More moment of couple, that is torque, is required to turn a heavy vehicle than that of a lighter one. Okay, heavy vehicle को मोड़ने के लिए हमको ज़्यादा टॉर्क चाहिए. To increase the moment of couple, the length of the couple arm should be more. More is the length of the couple arm, more will be the moment of the couple. Okay, so heavy vehicles are provided with bigger steering. Any doubt here in this question?
Yes, sir.
All of you understand?
Yes.
Let me verify with one of the students. Isan Gupta, is it clear?
Yes, sir.
Okay, good. Riya Kumari, is it clear? Riya.
Yes, sir.
Okay.
Sir, will you explain the second answer?
Second answer means this one on the screen.
Yes, sir.
Heavy vehicles require more torque, right? Heavy vehicles मोड़ने के लिए ज़्यादा torque चाहिए ना, because heavy vehicle and lighter vehicle, and so to increase more torque, right? Driver, suppose you are the driver, so you can apply suppose maximum of 100 Newton force. Okay, you cannot apply more than that force. Suppose, ठीक है, चाहे तुम you are sitting on the steering of a car or a truck, the force applied by you is limited. ठीक है, हम तो अपने I cannot apply force beyond my capacity. No, all of us. So force applied is constant. So what adjustment we can make so that the torque will be more? The other possibility is to increase the couple arm. The distance is more, the torque will be more, provided we are using the same force. Okay?
Yes, sir.
Is it clear or need more
No,
clarification?
sir, clear.
Okay. Please see question number 3. Calculate moment of couple and state the direction of rotation. Radius of the wheel is 5 centimeter and force F is 15 Newton. All of you know moment of force, or that is torque, or moment of couple, anything you can say, is force into couple arm. You see the force applied is 50 Newton, and couple arm means the diameter of the wheel or the distance between the two forces. Okay, So the diameter of the wheel is 10 centimeter or 0.1 meter. The answer is 5 Newton meter. Okay, easy.
Will be written, sir. Clockwise.
Clockwise or anti-clockwise?
Anti-clockwise.
Clockwise, the wheel will rotate anti-clockwise or clockwise? Think. See the.
Anti-clockwise.
It will rotate
Anti-clockwise.
anti-clockwise. Good. All of you see the diagram. Okay. It will rotate anti-clockwise direction. Rotation is anti-clockwise. Suppose two forces are acting. One force is here, another force is here. And the bar I'm giving you like this. Okay, the red one is the bar. Sorry. The red one is the bar and two forces are acting. Suppose F and this is F. Is this the example of a couple? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
So this is a couple. So where is the force is F perpendicular? Which one is the perpendicular distance?
Sir, downward.
Downward. So to find the perpendicular distance, you see the lines of the two forces. The top line, top force right side and bottom force left side. To extend, if I extend the lines, with the dotted line, okay, to perpendicular distance, now you drop a perpendicular. The blue line is the perpendicular distance. You see? Okay? You understand? The
Yes, sir.
perpendicular
Yes, sir.
distance is the blue line. So here we'll take a 5 minutes break. We'll join at 10:21. Now it is 10:16. Next topic is psychological gravity. Let's see on the slide. What is psychological gravity? The point at which the entire weight of a body can be considered to have is known as psychological gravity. Total weight of the object will act at certain point of the object. That point is called center of gravity. Okay? Once again, the net
distribution of mass. Distribution of mass. Anybody?
Then if the object is hollow, then also the center of gravity differs, and if the object is rigid, then also the center of gravity differs. Like in a circle, the center of gravity is at center, but in a hollow ring, the center of gravity will be at the center only, but there is no mass in it as it is hollow.
Okay, very good. So one point extra is that the center of gravity will shift towards the point where more mass is located. For example, take a bottle, simple water bottle, a plastic 1 liter bottle. I'm taking a bottle. What could be the shape? Suppose this is the bottle. Let me to draw a bottle. This is a bottle, water bottle, simple water bottle. Take some water in it, not filled, completely filled, but half filled. So if it is placed, if the bottle is placed horizontally, then water will come up to this level. Okay, I hope this is clear. Now I tilt this bottle in this way. Try to bear with the diagram. I have tilted the bottle. In this case, the water will lie like this. Okay. This part is water, and this part is water in the first bottle, first case. Same object, same mass, right? Same volume of water. Only I am changing the position of the bottle. In first case, the center of gravity will lie somewhere here. The dot I have placed. Okay. But in second case, the center of gravity will lie somewhere here. You see the two dots. Okay. So it means that when I tilt the bottle, the water will go to the downward direction. It means towards the bottom of the bottle. And so center of gravity will shift towards the heavier part of the bottle. In first case, you can see the position of center of gravity. In second case, you see the position of center of gravity. So remember, the center of gravity will shift towards that position where more mass is concentrating. Okay? Another example I would like to give. Suppose a triangle is taken. Can you tell me where is the center of gravity, upper part or lower part?
The lower part.
It would be somewhere here, the dot I placed.
Yes, sir.
Yes, sir. More mass is located towards the bottom, right? So the center of gravity will lie on that part where more mass is located. So this is the point number 2. The position of center of gravity depends upon the distribution of mass. More mass and center of gravity will shift to that position. Third point, position of center of mass changes if the body is deformed. Right? If you take a cylindrical can, right, and hollow, so center of gravity will lie exactly at the middle of the can. But if you crash it, the center of gravity, the position of center of gravity will change, provided the mass or the weight of the object is not changing, but the position will change. So obviously, first point and third point is saying the same thing. As you change the shape of the object, so position of center of mass or center of gravity will change. Okay, first point and third point saying the same thing. Second point and fourth point also say. Fourth point you can see center of gravity shifts towards the heavier part of the object. So already I have explained object, okay, in which mass concentration is more, towards that part the center of gravity will shift. Okay, more mass, the center of gravity will shift to that. Second point and fourth point almost saying the same thing. Point, it is not necessary that the center of gravity always be within the material of the field, right? Already one of you have said if you have taken a ring, the center of gravity will lie at the center of the ring. Okay, and where no material is there. The fifth point, you can see the center of gravity may lie at a point where no material of the body is there. Example is the position of center of gravity of a hollow object. Hollow object, or if you take a ball, football, where will be the center of gravity? Anyone?
At the center where there is no mass.
And yes, at the center of the football. Is there any material with the center of the football, at the center of the football? No. So it is not necessary that material must be there where the center of gravity is lying. Not necessary. Next point you can see, center of gravity lies on the geometrical center of the regular body. Regular body like football or a sphere, the center of gravity will lie at the center. And the last point, important point, the algebraic sum of moment of force due to the weight of all the particles of the object about center of gravity is 0. The last point is very important point. The moment of force, okay, due to the different particles about center of gravity is 0. Okay, so these are the few points about center of gravity. We'll discuss the last point. You can see the regular objects on the screen and the position. You can see rectangle. So center of gravity of the rectangle, you can see square, circle, sphere, rod, cylinder. The center of gravity will lie at the geometrical center. Okay. Any doubt here?
No, sir.
No, sir. For clarification, I would like to ask to any of the student, I'll go to Varsha Kumari. Is it clear? Varsha? No response? Ankush, is it clear?
Yes, sir.
Okay. So please keep these things in your mind. Next day again I'll discuss center of gravity, how to find center of gravity of irregular bodies, and few conceptual questions about center of gravity. Okay, next class. Okay. Thank you. Thank you very much to all of you.